Welcome everyone. Today we are solving problem number 7.53, which I have already written for you guys due to my time consuming issue. So we have two circuits given in the problem number 7.53, right? So they have asked us to determine the inductor current IT for both t is greater than 0 and t is less than 0, right? For this circuit, let's just consider this circuit. Okay, let's just consider this circuit. For t is less than 0, what we can see? For t is less than 0, this switch will be closed when t equals to 0. This switch will be closed at t equals to 0, t is greater than 0, right? Before t is greater than 0 or t equals to 0, the switch will remains off, right? If the switch is off, what will be the current? Before t is, if you consider for t is less than 0, this switch will be opened and the whole current will be passed through this loop, right? Whole current will pass through this loop. If the whole current will pass through this loop, it will be in steady state mode, and if in the steady state mode, we can easily say that the current through the inductor, or we can replace the inductor as short circuit. So the current through the inductor will be 25 divided by 3 or 3 and 2 are in series, so it will be 25 divided by 3 plus 2, right? So for t is less than 0, I0 negative equals to I0, because we know the inductor current cannot change rapidly or drastically. So the current through the inductor I0 minus equals to I0 equals to 25 divided by 3 plus 2 divided by 5 equals to 5 ampere, right? So the current will be current through the inductor will be I equals to 5, I0 equals to 5. Now if we want to calculate the current after the switching, if we switch this out, this whole terminal will not get any sort of current because it will be short circuit. So the voltage will be the current will be go through 3 ohm and then pass through this terminal and will get back in the voltage source again. So there will be no current in the 2 ohm and the inductor. So after t is greater than 0, the I infinity will be 0 and the tau will be L by R. For inductor or for RL circuit, we know tau equals to L by R, or time constant tau equals to L by R. So for this inductor, tau will be L divided by R Thevenin. So what is the value of R Thevenin? R Thevenin will be, if we close this out, the R Thevenin will be just 2, because if we close this out, this 3 terminal will be no longer as counted in the circuit, because this will be closed and the current will be passed through this terminal and remains back and this loop will be continuous. So if we want to consider this circuit, the RTH will be only 2 ohm. Okay, the RTH will be only 2 ohm and the time constant will be L by R. What is the value of L or inductance? It will be 4 Henry, and the value of RTH or R equals to 2 ohm. So the tau will be L by R equals to 4 by 2 equals to 2 seconds. Okay, so we already know all the things we needed to know: I0, I infinity and tau. So we just implement this: IT equals to I infinity plus I0 minus I infinity e to the power minus t by tau 5 e to the power t minus t by tau ampere. It will be the answer for this circuit. Now let's head back to this circuit. Now if we want to head back to this circuit, for this circuit, what it says, the switch will be opened when t equals to 0. It does mean that switch is closed now, right? For t is less than 0, the switch is closed now. If the switch is closed now, we can easily say that whole circuit is in steady state mode, right? If the switch is closed now, it does mean that switch is on before while ago. It may be in infinity time, so negative infinity also. So the switch is closed now. Before t is less than 0, the switch is closed now. If the switch is closed, the whole circuit is in steady state mode, and in steady state mode we know we can replace the capacitor as open circuit and inductor as short circuit. So if we replace the inductor as short circuit, the current will pass through this terminal and will not go through this 4 ohm or 2 ohm. This terminal and went back to the circuit again. Okay, so there will be no current flow in 4 ohm and 2 ohm, and the whole current or I will be as equals to the 6 ohm ampere. Okay, so which we have written already. For t is less than 0, the inductor we can replace as short circuit, and the whole circuit will be in steady state mode, and the I0 will be 6 ampere. Okay, now after t is greater than 0 or t equals to 0, the switch will be closed. Switch will be opened. Switch will be opened. Okay, switch will be opened. Then if the switch will be opened, then there will be no current flow through, because the current will not have a path. To enter the inductor, right, or inductance. So the current will no longer going through this terminal and the I infinity will be 0. which we already written, the I infinity will be 0. Now let's calculate. We have already got I0, we have already got I infinity. Now we have to calculate tau. What is the value of tau? We know in RL circuit the tau equals to L by R. Tau, the time constant value, equals to L by R, or inductance divided by RTh or R Thevenin. For this, what is the value of R Thevenin? If we replace this out or consider through these two terminals, or in these two terminals perspective, the R Thevenin will be just 2 ohm, because this switch is opened. So no longer this will be counted in our circuit. So that R Thevenin will be only 2 ohm, right? So the the time constant tau will be L by R, which will be 3 by 2, which we already have written 3 by 2. Now just calculate the whole thing out. So it equals to 6 e to the power minus t by 3 by 2, 6 e to the power 2 by 3. So this will be the answer for our circuit or problem 7.53. I guess you guys have enjoyed the video. Thank you very much.